In the previous video, we saw array optimization technique, which is the sliding window technique. In this video, we will see the two-pointer technique. And for that, we are taking a LeetCode question, which is container with most water. Let's see the problem statement. The problem statement is taken from LeetCode. You are given an array called as height, and it has non-negative integers, and each element in the integer represents the coordinate I comma height of I. N vertical lines are drawn such that two endpoints of line I are at I comma 0 and I comma height of I. Find two lines that together with the x-axis form a container such that the container contains the most water, and return the maximum amount of water a container can store. First, we will try to understand what the problem statement is. The problem statement is, we are given a container in terms of an array, and we have to find the container that can hold the most amount of water. The input for this is actually an array called as height. Let me take the same example found in LeetCode. 1, 8, 6, 2, 5, 4, 8, 3, 7. The subscript for the array will be 0, 1, 2, 3, 4, 5, 6, 7 and 8. The way we have to visualize this problem is, the subscripts form the values along the x-axis, and the elements themselves form the values in the y-axis. It has values 0, 1, 2, 3, 4, 5, 6, 7 and 8. And we see that the values here are between 1 and 8. So it is between 1, 2, 3, 4, 5, 6, 7 and 8. The 0th element has a height of 1. The second element has a height of 8. The third element a height of 6. Is 2, followed by 5, followed by 4, followed by 8, 3 and 7. The problem statement is, I have to find the rectangle that is formed by two lines and the x coordinate. For example, this is one line formed by the x-axis, and these are two other lines. So I can form one rectangle like this. Another rectangle that I can form is using these two and then the x coordinate. Like this, it is possible for me to draw numerous rectangles. The problem statement says, find that rectangle which has the maximum area. Let's see the first one formed between 0 and 8. The width will be 0 minus 8 minus 0, which is 8, and then the height of the smaller line is 1, so the total value is 8. Now let's try to find the rectangle between 1 and 8. The width will be 8 minus 1, which is 7, and the height will be the height of the smaller line, which is 7, so the total area will be 49. Let's try to find the rectangle between 1 and 6. Between 1 and 6, the width will be 5, and between 1 and 6 both are of the height 8, so the height will be 8, and so the total area will be 40. The problem is we have to find the rectangle which has the highest area, and so the output that we are expecting is 49. We will solve this problem using a two-pointer technique. We will use 2 pointers, one we will call as the left and one we will call as the right. Then we find the area, and here our area is 8. Now let's look at the smaller line. The smaller line is at 0. So we move the left pointer from 0 to 1. Next we find the area between 1 and 8, and now the area is 49. Initially we would have said that this is max. This is just like finding the maximum in any array. So this is represented as max. Now we have found an area which is larger, so we would have changed max to 49. Here the smaller line is represented at the right, so we move the right pointer from 8 to 7. And then we find the area between 1 and 7. So when we find the area between 1 and 7, we find that it is a value less than 49. So we will retain this to be the max. Like this, we will move the left and the right pointers depending on in which position the smaller line is found. And we will keep updating the maximum area. In this manner, we will be able to get the container that can hold the largest amount of water. We define a function called as max area, and we pass the array. We have already mentioned that left starts at 0 and right starts at n minus 1. Initially, let the max area be 0. Now, we have to keep moving the left and the right pointers as long as left and right are not in the same position. There should be at least one difference between the subscripts of left and right. We calculate the width as the difference between right and left, and we calculate the height as the minimum between the two lines. That is, whether it is the height of left or the height of right, the minimum is going to be the height of the rectangle, and then we calculate the area. If the new area that we have calculated is larger than the previous area, then we update the maximum value. Then we have to decide which pointer should be moved based on the height. So if the height of left is less, we move left, else we move the right. Let's see the time complexity. Note that the only loop that we have is the while loop. There are no inner loops, and so the maximum that we will go up to is a big O of n, because the left and the right are moving in such a way that they start from the first and they move to a position where they are in adjacent positions. So the maximum we will move is only in n elements, and every other statement which is inside is done in a big O of 1 time complexity, because even the minimum and the maximum values are found only between 2 elements. So the time complexity of the entire function is big O of. We write many test cases to check its validity. We first take the example which is given in LeetCode. Then what if we have a rectangle in which both are of the same height. What if we have small and then increasing and then decreasing heights? Then we check the edge test cases. What if everything is 0? In which case it has to return a 0. What if it has a single tall line like a single small value 100? What if there is a large drop in the middle? What if the lines are in decreasing order? What if the lines are in increasing order? And what if we have a very large input? Our program passes in all the test cases. When we look at the space complexity, other than the input array height, we have not used any extra intermediate data structure other than the simple variables like width, h area, and max area. All these are negligible because they are just going to store single values, and so the space complexity is big O of 1. If we had used an intermediate data structure to do the processing, it would have increased. But now, since we are only using small variables holding a single value, the space complexity is going to be big O of 1.